Multidimensional arrays. It turns out that Java really only has one-dimensional arrays. So when you are processing what appear to be multidimensional arrays in Java, what you're actually processing are arrays of other one-dimensional arrays. So for example, take a look at this declaration of the array B with two sets of square brackets. That indicates that B represents a two-dimensional array with rows and columns. Now we've chosen to hard code an initializer list in this declaration, and the way the compiler figures out how many rows there are from the initializer list is by counting sub-initializer lists. Now this is extremely important because the compiler has to figure out how to dynamically allocate this array called B. So if you're going to use an initializer list to initialize a multidimensional array, you have to have a properly nested initializer list to help it calculate the proper number of elements in each dimension. So it counts our two sublists, figure out that there's two rows in this case, and then for each row it counts how many values are in that row. So the first row has two elements, and then the second row has two elements. You might refer to this as a rectangular array because each row has the same number of elements. And as far as how this initialization works, the two elements in row 0, b sub 0 sub 0 and b sub 0 sub 1, are initialized with 1 and 2 respectively, and the two elements in row 1, b sub 1 sub 0 and b sub 1 sub 1, are initialized to 3 and 4 respectively. Now I mentioned that because of the fact that it has to count all of the initializer values in each of these sublists to figure out the length of the sublist and therefore the length of the row, you can actually have rows of different lengths, or what we might refer to as ragged or jagged arrays. So here's another declaration for an array called B with two dimensions. Notice we have two sublists. One of them contains the values 1 and 2. The other contains the values 3, 4, and 5. So we have a 2-element sublist and a 3-element sublist, and row 0 in this case contains just the values 1 and 2, and row 1 contains the values 3, 4, and 5. And you may say, well, how does it know what the lengths of all of these pieces are? And the reason it knows is because each piece is a one-dimensional array, and every one-dimensional array in Java knows its own length. So it maintains an array, a one-dimensional array that represents how many rows there are. Every element within that array represents a reference to another one-dimensional array, and that one-dimensional array knows how many columns there are. That's the length of that one-dimensional array. Now you may be wondering, based on this, how would I dynamically allocate a multi-dimensional array? And we show you that in the next slide here. Let's assume we wanted to create a 3-row and 4-column array. We can allocate such an array as follows. We've first declared the array B as a 2-dimensional array, and here we're saying that B is a new integer array with 3 rows and 4 columns. So this would allocate a rectangular array of 3 rows and 4 columns. However, if you wanted to allocate different numbers of columns for each row, that requires a little bit more on your part. You still declare the array the same way. In this case, again, B has 2 dimensions. But you start out by allocating just the first dimension. So what this says is that B is going to be referring to a new array of integers that has 2 rows and some number of columns per row. So what this part does is it indicates that the array has 2 elements in it that represents the rows, and it also indicates that each of those elements refers to a one-dimensional array of type integer. Then we go and allocate those one-dimensional arrays of type integer, and we say that the first row of the array, b sub 0 represents the first row, is assigned a new integer array of 5 elements. So now row 0 has 5 columns. And then b sub 1 has a new integer array of 3 elements, so now the second row contains 3 columns. So you can in fact dynamically allocate both rectangular and jagged arrays.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.